I won't go through everything. Part one, we looked at Bronsted-Lowry acids and bases. We just talked about that in the exam outline, though. An acid donates a proton, a base accepts a proton. Okay. What is the difference between a strong acid versus a weak acid? What does a strong acid do that a weak acid doesn't? Ionizes 100% or dissociates 100%? Less than 100. It's usually way less than 100, and it's in your data booklet, which you will get on the test. All the stuff up here ionizes 100%. Everything else is less than that, and quite a bit less than that. Okay. What does amphiprotic mean? Can act as an acid or a base. So basically, anything that has protons and a charge will act as an acid, or it can be amphiprotic. So H2PO4 minus 1, if it acts as an acid, it'll donate a proton, and you'll get HPO4 2 minus plus H3O plus. That's it acting as an acid. If it acts as a base, it will accept a proton. That's probably not the best example because isn't phosphor? No, it's not. Nope. It will accept a proton to form that. Yeah, because it'll accept the proton, which is positively charged. I mean, you could force it. That's not chemistry. We do. For our purposes, yes. You like it when I say, for our purposes, you could exclude all that stuff, but just, yeah. Okay. I went through all that. Hydrolysis. So this is the acidic or basic salts. Remember these? So say I have K. What would be negative? Potassium fluoride. So do we ever care about the alkali metals? No, we ignore the alkalis. So essentially, alkali is a spectator. So really, we just focus on this F minus. When you put it into water, it dissociates into potassium ions and fluoride ions. We don't care about potassium. F minus will react with water to do what? It'll accept a proton, right? Okay, so is this a acidic or basic salt? It's a basic salt because we produce OH minus. Okay, So KF is a basic salt. All right. What happens if you have something like this? Sodium bicarbonate. Okay. Do we care about the sodium? No. So really, we're just focused on the bicarbonate. So what can happen here? We have a negatively charged molecule with a proton. So it can act as an acid or a base. You have So you have to figure out which it's going to do, because it can act as an acid and go this way. H3O plus, CO3 2 minus. This is it acting as an acid. That would mean you need to know the Ka. Or it can go this way and act as a base, in which case it accepts a proton. And you get that. And that's the Kb. So the Ka, so you have to compare which one is stronger, which direction does it go? And it's going to be dependent on the strength of the Ka versus the Kb. Ka you can pull right from the table. What's the Ka of HCO3? I'm actually asking you. 5.6 times 10 to the minus 11. Okay, so now we got to figure out the Kb. How do you figure out the Kb? So you're going to use Kw. So we know that Kb is going to be Kw over Ka. Ka of what, though? The conjugate acid, this one. Carbonic acid, right? It's not this acid. It's not of this, because that has a specific Ka. This is the reaction we're looking at. So you form this. So it's what is the acid of this that's pushing back? Okay? And that will allow you to calculate the Kb. So Kb is going to be Kw over Ka of that. The Ka of the carbonic acid is 4.3 times 10 to the minus 7. People agree with that? So if you divide those off, you're going to get 2.3 times 10 to the minus 8. So now you have a direct comparison. The Ka of bicarbonate is 5.6 times 10 to the minus 11. So it's pulling that way with a certain amount of strength. The Kb, where it goes this way, is 2.3 times 10 to the minus 8. Which is the bigger number? The Kb. Therefore, it acts as a base. Okay? Therefore, sodium bicarbonate is a base. Or a basic salt, I guess we should say. Does that make sense? Okay. Oh, excuse me. Let's do part 2 quickly. buffers. How do you make a buffer? So you use a weak acid and its conjugate base. That will give you an acidic buffer. Or you can do a weak base and its conjugate acid. Let's give you a basic buffer. So if that's a reaction, weak acid, conjugate base. Ka of this would be that. What do you do to maximize? Thank you. What do you do to maximize the buffer protection? Yeah. There you go. You make this and this equal concentrations because that gives you protection on either side, right? If those are equal, then they cancel out in that expression and you get Ka is equal to the concentration of H3O plus which if you rearrange that equation, you can get, I'll just give you the quick here. The Ka is equal to 10 to the negative pH. So if you need the Ka of the buffer, because we only dealt with stuff where it's equal concentrations. If you need the Ka of the buffer, it's 10 to the negative pH, and it would be the middle part of the pH, right? Because that's a transition point. Okay. If you did, let's do. Anhydrides. So there were two types. There was metallic anhydrides. K2O. That's not K2O. Metals and non-metals. Basically, there was two trends you had to remember. Does anybody remember the trends? So here's the metals, if this is the periodic table. And there's the non-metals. If you remember acid rain, you can do this. So, covalent molecule, CO2, reacts with water to form what? H2CO3, carbonic acid, acid rain. All right, so the non-metals are acids. The metals are bases. Sorry? Alkali metals are on the left side of the periodic table. And alkaline, yes. I think that's most. Oh, pH curve. That's the last thing. And then we're done. There's no acid rain question or anything like that. You want an acid rain question? Bonus question? No. Yeah.
Hey, Walden, can you put a bonus question for each unit that we did?
All right, pH curves. If you mix a weak acid with a strong base, where will your equivalence point be? A weak acid with a strong base. Higher pH, right? It'd be greater than 7, right? Depending on the strength of the acids and the bases. Strong acid, weak base. Lower. I'm drawing bad curves here. And what if it's strong and strong? Oh, sorry. That would confuse people. All right, pH 7.
What if it's weak and weak?
Depends on the weakness. But that's not going to work because these are for titrations, right? So that's how you pick your indicators.